Bismillahirrahmanirrahim. Assalamu alaikum to all of you. Here you can see that the chapter number 10 area arc length and the area of the sector. This is the chapter number 10 of D3. I'm going to draw a circle with the help of this compass. You can see that the center of the circle is marked. This is the center of circle. Say I have named this center as C. Now I am going to draw the radius of the circle. Before drawing the radius of the circle, let me darken this circle because I think so there may be the problem of visibility. Well, so this is a circle with center C. Here, this line is mentioning the radius of the circle. This is the radius of the circle R. C is the center of the circle, and this line, the outer line, this is called the circumference of the circle. These things, I hope you people are aware of all these things. Now, what a new thing which I'm going to introduce. If I am going to draw a line like this line, which I am going to draw. This is the line, say this is PQ line. This PQ line is called the chord of the circle. PQ is called the chord of the circle. CHORD. PQ is called the chord of the circle. Any straight line which is touching the circumference at 2 points is called its chord. Okay, this PQ is the chord of the circle. As you know that any line, any straight line which is passing through the center of the circle, that chord, because there may be too many chords. I have drawn one chord PQ. So in the same way, if I draw another circle, for example, here I am marking the center C, and I am going to draw the circle like this. Say this is the circle with center O. Now, if I am going to draw chords like this, these all lines which I am going to draw are called chord of the circles. Okay. These all in any direction. It is not necessary that a chord may be drawn in one direction only. Now, as you know that if this chord is passing through the center of the circle, if I am drawing a chord which is passing through the center of the circle, this chord is called diameter of the circle. So you can draw as many as possible chords. So the chords which are passing through the center of the circle are called diameter. You people are already aware of the concept of diameter. So it is not necessary that chord may be in one direction. The chord may also be like this. So these all lines are called chord of the circle, CHORD, chord of the circle. So if this chord of the circle is passing through the center of the circle, so this is called the diameter of the circle. As you know that diameter is the double of the radius. Diameter is equal to 2 times of radius. So if you are doubling the radius, then it will become the diameter. As you know that if I am going to draw the radius like this, joining these two radius like this is also radius. So this total length starting from this point till this point, say this is AB. AB will be the radius. Diameter. AB is equal to 2 times of radius. Okay, now, as I told you that This is the chord of the circle, and there may be too many chords of the circle, as many as in any direction you can draw too many chords of the circle. Now let us discuss another thing. I am going to draw another circle, mentioning the center like this. So this is another circle. Say this is the center of the circle O. Now I am going to draw I am dividing these circles into two arcs. If I'm dividing the circle by diameter, then you can see that this half upper circle and half lower circle. So circumference is being divided into two parts. This ACB and ADB. I'm naming this ACB and ADB. The upper one is also half circumference, and the lower one is also the half circumference of the circle. This is when you are dividing a circle with the help of the diameter. Now, if I am not dividing from the diameter, if I am dividing the circle with the help of the chord, for example, this is the chord which I am drawing. Now, if I am joining this chord with this line, so this is the radius of the circle. From this side, it is also the radius of the circle. Say this is EF. EF is the chord of the circle. Now you can see that EAF is a major arc, and EBF is the minor arc. Major mean bigger one and minor mean smaller one. So this is the major arc of the circle. The lower one is the smaller arc of the circle. Okay. So remember this. If this is the major arc, then the angle will be greater. This is called major arc. Major arc. And this is the minor arc. Minor arc. Minor arc name EBF is the minor arc, and the major arc is EAF. EAF is the major arc. And against the major arc, there will be greater angle, and against the minor arc, there will be smaller angle. Remember this thing. Okay, now I am shading a region. This region, if I am shading, this is within the major arc. So obviously the region which is within the major arc is called the major sector. Major sector. And this is called the minor sector. Minor sector. Major sector, major arc. Minor sector, minor arc. And I told you that the angle in the major sector will be the greater angle, and in the minor sector, it will be the smaller angle. Okay. Well, now let us divide this circle in other way also. I am going to draw the circle again, mentioning the center of the circle like this. Here you have to observe that how I am going to divide the circle. Previously, I did not consider the chord. Now here, if I am considering this chord, say, this is the chord, say this is chord AB. I have drawn a circle. I have mentioned a chord AB. If I am dividing the circle with this chord AB, then this circle will be divided into two parts. I am shading the upper part and leaving the lower part unshaded. This upper part will called major segment. Major segment, because this is bigger one. Major segment. Major segment, and this is minor one. Minor segment. This is the minor segment, which is smaller one. So major is the bigger and minor is the smaller. On the contrary, here, if I am dividing the sector like this, so this will be the major sector and this will be the minor sector. Under the minor arc, this will be the minor sector. But if I am dividing it like with the help of a chord, so this will become the major segment and this is the minor segment. These are the basic concepts which you must remember. Okay, so I hope many of you are aware of these ideas. As you know that circumference of the circle, circumference represented by C, and if the radius of the circle is r, then circumference, you know that this outermost boundary of the circle is called the circumference of the circle, which I am mentioning with the darkened line. So this line which I am drawing is called the circumference of the circle. So C is equal to 2 pi r. 2 pi r. As you know that the diameter d is equal to 2 times of radius. So 2 times of radius is the diameter. So the formula for circumference can also be pi times d. Okay, because 2 times r is the diameter. So instead of 2r, I have written diameter, and pi will become as it is. So for the circumference, you can use 2 pi r or pi d. Okay, for area of the circle, you know that pi r square. This is the formula to find out the area of circle. Okay, I hope this is clear to you. Another very important thing, if somebody asks you to find out the perimeter of a sector, I am going to draw a thing like this. For example, this is the center and I am drawing not full circle, but this much of the circle. I have mentioned an arc instead of drawing the full circle, joining with the center like this. Let me join it with the other color. Well, so this is the radius of the circle. A, B, C. ABC is the arc of the circle. Now, if somebody asks you to find out the perimeter of this sector, this is a sector of the circle, as I told you, this is a sector of the circle. Okay, so if somebody asks you to find out the perimeter of sector, perimeter of sector, what you are going to do, you must know this length of arc plus 2 times of radius. As you know that perimeter is the outermost boundary of the given shape. This given shape is a sector. This sector is consisting of an arc which I have shown in black color, and there are 2 radii which I am mentioning in green color. So basically, to find out the perimeter, what you are going to do, length of arc ABC plus 2 times of radius. So this will be the perimeter of this sector. Now, how we are going to find out length of arc? This is also must be known to you. This the formula for length of arc. Length of arc. If this angle, say this angle is theta, then length of arc is equal to theta, or whatever this angle may be, theta over 360, because the total angle in a circle is 360 degree, into 2 pi r, or theta over 360 into pi d, whatever deem fit you can use. Okay, so this is the formula for length of arc. It means if you are going to find out this black line ABC, this black arc, then this formula will be applied. Length of the arc ABC, I mentioned length of the arc ABC, this can mention that this is the length of the arc. Okay, so this can be calculated with this formula, and then you have to add 2 times of radii, which will give you the perimeter. The total will give you the perimeter of the given shape. Well, now move to the exercise. Please take out exercise 10A. Exercise 10A. Question number 1. Exercise 10A, question number 1. It is given that find the diameter of the circles given the following areas. In A part, the area of the circle is given. Area is 616 millimeter square. This is the area of the circle. And we have to find out the diameter, because it is given that find the diameter of the circles giving the following areas. Diameter is required. You know that the formula for area of circle is area of circle is equal to pi r square. You have to apply this formula. Here area of circle is 616. 616 is equal to pi. I am taking pi 22 over 7. It is up to you whether you can take 3.142 or 22 over 7. If it is given in the examination or in the question that the pi will be taken 3.142, then you will have to take 3.142. Otherwise, you can take whether 22 over 7 or 3.142. Normally, if this type of question comes in P1, then obviously you will have to take it 22 over 7. Now 28 multiplied by 7 gives you 196. 196. So r square is equal to 196. You will have to take the square root. So radius is equal to 14 millimeter. Diameter is equal to 2 times of radius. 2 times multiplied by 14 gives you 28 millimeter. So this is the part 1 of part A of question number 1. Now I am going to solve question number 2. It was very simple. So rest of the 2 parts you can do, and you can do them as a homework. Question number 2. In question number 2, what is given basically? Find the areas of the following rings whose external and internal diameters are given. Here, how these rings can be drawn. Actually, they have shown you that whose internal and external diameters are given. So I just want to show you the shape like this. If this is the center of the circle, first of all, I am going the internal circle like this. Please observe if they are saying that internal and external diameters are given. So here I am going to draw a circle. First of all, I am going to draw this circle and then external circle. External mean outer one. So this is the outer circle. There are two circles, internal and external. So they say this diameter, the internal diameter is given. I am mentioning internal diameter with 15 centimeter. And for the external diameter, I am using a black line. This external diameter, obviously the greater one will be the, sorry, uh, this is internal is 13. Internal is 13 and external is 15 centimeter. Obviously the external will be the greater one and internal will be the smaller one. So what we have to do, we have to find out the area. This area is required to be found. He is saying that find out area of the ring. From here, I think so you people are aware that how we are going to find out. We are going to subtract the internal area from the external area, because external area is greater. From the external area we are going to subtract the internal area. So here I can mention that the greater D for the external diameter 15 centimeter and smaller d for the internal diameter. These are the alphabets which I am using for this. For the external radius, I am using capital R, 7.5 centimeter, and internal radius will be 6.5 centimeter. You know that half of the diameter is called the radius. Capital is mentioning the external radius, mean from this center till this one, this which I'm mentioning with red. This is the external radius, which is 7.5 centimeter, and the internal radius, this is 6.5 centimeter. Okay. Now I'm going to find out the area of ring. Area of ring is equal to pi r square minus pi r square. You can also solve it separately. If you feel it like that separately, you can find out the area of the external and then area of the internal, and then you can subtract them. Okay. So students are giving me different answers. Let me see what is the correct answer. 7.5. 7.5 square minus 6.5 square. Okay, this is 14. 14 divided by, obviously, that 22 over 7 into 14. 7s are 7. 7 2s are 14. So this is 44 centimeter square. So this is the area of. Question number 3, part B. You can see square is given because all the lines, all the sides of the square are equal. Now this has been divided like this. Here you can see that these are the arcs, mean quarter arcs of the circle. These lines are showing that these are the radii from the center. From each center, the radii are given. And this is the shaded region. The shape is given like this. This is the shape which I am going to draw. Here you can see that these are the quarter arc of the circle. At the corners, there are 90-degree angles. These are the quarter circles. Let me explain you that how they are quarter circles like this. If I am drawing this a circle like this, for example, look here very carefully. If I am taking this one is the radius of the circle, so this will be the arc of the circle like this. Okay, so this is the radius of the circle. So let me draw the same size of the circle. Ignore this. So if I am going to draw this circle into 4 parts like this, so each part of the circle is called quadrant. So these are 4 arcs, 1, 2, 3, and 4. So 4 arcs are surrounding this shaded region. Here we have to find out the area and perimeter of the shaded region. As for the area is concerned, it's very simple. You can see that the total is 14 centimeter. This length is 14 centimeter. It means the radius of the circle will be 7 centimeter. So you can very easily find out the area of the shaded region. Area of shaded region is equal to area of square minus area of full circle, because these 4 quadrants are making one full circle. So from the area of the square, I am subtracting the area of one circle. So area of square is side multiplied by side. 14 is the side of the square. 14 multiplied by 14 minus pi r square. The radius r is 7 centimeter, because from center till the circumference, this is the radius of the circle. 7 centimeter is the radius of the circle. Applying the values, you can find out very easily that 14 multiplied by 14 gives you 196 minus 22 over 7 into 7 into 7. 7 is cancelled. 196 minus 154. 154 minus 196, you got 42 centimeter square. This is the area. Now, as for the circumferences of this perimeter of this shaded region is concerned, this perimeter is consisting of the full circumference of the circle. Perimeter of shaded region. Perimeter is of shaded. This perimeter is consisting of the length of 4 arcs which are making one full circle. So instead of finding out separately one length of one arc, then you can directly apply the formula that pi d or 2 pi r. I am applying pi d because I told you that there are 2 formula. 22 over 7 into the diameter. Diameter of the circle will be 14 because 7 is the radius. So 14, 7s are 7, 7 2s are 14. So this is 44 centimeter. This is the perimeter of the shaded region. Okay, I hope that this is clear to you. If you have any question, you can ask that the